There we go. Yeah, so welcome anyone who's listening to the recordings. Um, yeah, so you just want me to just go through the stuff that I had planned, or
Sure.
okay. Um, so I've gone through these slides a few times, but it's always good to just do them again. Um, So right here, we're actually looking at the definition of, for the word method in like a dictionary, just the normal English definition for a method, procedure, technique, or way of doing something, especially in accordance with a definite plan. Um, and so that holds true to coding as well. Methods are a way of us being able to break up specific tasks, and hopefully that task maybe has like a label for what it was doing. Um, maybe you have a method that's like a get input, and then that's what you're doing within that method. Um, and a pretty good indication that you should be using a method instead of just having everything living in your main code, is if you see a lot of code that's sort of duplicate, like stamps, like actual like stamps within your code, where maybe only a constant, some number is changing between where you have the same looking code, um, the same 4+ lines over and over again. It's a pretty good indication that you should probably be using a method. Also, methods can help clarify things. So maybe you have one line of code that's really, really ugly that you have all over, like that same line of code you have all over in your code. You're using it everywhere. But looking at that line of code isn't very clear. What you can do is that you can make a method of saying, what is it doing? Maybe it's taking the average, the average of three numbers or something like that, or maybe it's just getting the middle number, or the greatest number, like the min or the max number, and you have that code and you're using that code all over the place, and it's not, the code isn't quite very clear by just looking at those few lines. What you could do is that you can just stuff that into a method and then call the method get maximum integer or something. And then everywhere where you'd use it, you'd say get maximum integer, and then that makes your code much more readable. And anyone who's actually interested in figuring out how you're figuring out the maximum number or whatever, they could go and look at the code in the method. So methods are very, very useful. We also call them member functions. In Java, because everything is in a class, everything is a member of a class. But in languages like C++, that's not quite the case. You have some things that are in classes and some things that are out of classes. And so that's why we have sort of that vocabulary duplication. So in Java, we pretty much refer to them as methods, but they're also called member functions because they're a member of a class, because everything is a class. But if you're talking to somebody who's programming C++, just be mindful that they might use function, they might just say function, but what they really mean is member function, which is a method. Got to throw more words at you. So that's methods. Any questions about methods?
No, I think I feel pretty comfortable with methods.
Cool. Excellent. Okay, let's talk about arrays. So we've used arrays. Double check. I think some of my C++ stuff snuck in. That's the issue about stealing slides from my previous class, is most of the syntax works perfectly fine, but I don't think you can do this. Right. You need to say equals new boolean. Let's see. I need a So square brackets somewhere. There we go. Yeah, so something to be mindful. This is how you do it in Java, and in C++ you can get away with this shorthand. So let me just correct this slide. Let me just clean up these. All right, something like that. Okay, cool. Yeah. So, do you recall what a Boolean type is?
Yeah,
What does it hold?
a true or false value, like a
Yeah.
0 or a 1.
Yeah. And they're very, very useful. I mean, that's how all data is stored in computers, and is a good way of being able to make decisions within code. But also, anytime maybe you want to store whether or not it's this player's turn or that player's turn, where things are these binary options. This is a great data structure and gets overlooked a lot. And so something that I had said at the beginning of the semester was always look at your data type and see what is the smallest data type that you can use to achieve what you want to do. Yeah, to achieve what you want. A lot of times people will make these really big, bulky data types that's really not necessary, that you could just use a Boolean for it. I mean, I've seen people use floating point numbers like doubles for things that they could really be using just a one Boolean for. So yeah, something just to be mindful about, to always use the smaller data structure. So the way that we use arrays most of the time is in using the strategy called partially filled arrays. And what this means is that part of the array has stuff in it that we care about, and the other part of the array has stuff in it that we don't care about. And the way that we keep track of that is that maybe we have some kind of variable, maybe we call it size or whatnot, and that tells us how much of the array is garbage, how much of it do we care about, and how much of it is garbage and how much do we care about. So, and when we first start out with a partially filled array, when we create it, in Java, these are all set to false. But just be aware that in other languages, that's not the case. But also, if we're doing anything that's not a Boolean type, like we're doing an integer, these all start at 0. And 0 might not be a good default value for you. So just something to be mindful about, that just because there might be values in the array in all of these positions may not mean that those values mean anything important to you, especially in the case of a partially filled array. And so what we do is we keep track of where we filled it, where we put data in it. So here's an example. We make capacity 6. So actually this should be 6. And then we set the size to 0, meaning that nothing in the array is anything we care about. And then we set the first position to true and the second position to false. So here we go, we have true and false. And then we set size to 2. So size tells us how many of the spots in the array are valid that we're using. And it also gives us the index for the next spot. So we could say, for like the next line, we could say b at size plus plus equals true. And we could literally just keep running this same exact line, maybe in a loop, and that would set this one to true, and then we run it again, this one to true, and this one to true, and this one to true, because this is a post increment. Because the first time we run this particular line, size is 2, which happens to be pointing at this spot in the array. Yeah, and so if we use any more complex data structures like an array list or something like that that Jeff will introduce later, all it's doing behind the scenes is the same thing. It's using a partially filled array. It's just hiding it from you. It just makes a really big array, and you tell it, here, have another item, and it just inserts it into the array. And when you ask it for the back, the back thing, it just goes at size -1 at the array, and then gives you that element. Yeah, so this is a very useful strategy for dealing with arrays and dealing with input in general. If you're taking input from the user, for example, this is one of the ways, and you need to store the actual input from the user. This is a way to do it. What type would you change this to?
To store input from the user?
Yeah. Maybe we want to store exactly what they typed in.
So it would be a string then, right?
Yeah, exactly. And so we could make a string and then whatever size it is, and then we can make decisions based on, if we're full, like if we say size is hit capacity, like size is hit capacity, we could tell the user, oh, we're full, or we could do other things like we could make a new or yet another array that's twice as big, and then copy over all of the stuff, all of the elements, and then keep consuming input. There's lots of different strategies for that. But yeah, but the way that you would keep track of that is that you'd have these two variables. You'd have your capacity, and then you would have your size. And actually, an array has a size, but I like to store them in separate variables, because maybe you want to use it in some kind of for loop or something. And inside of here, where I have 100, it should really be capacity. So let's just adjust that. There we go. And we can chuck this line here. And then might as well add that. Okay, cool. Yeah, so that's partially filled arrays. And that's really how everyone should use arrays. is keep track of, have some kind of line where where you have data that you're using, and where there's garbage, and then where there's data that's valuable too. Okay, classes. Not like the class that we are in right now, but as in a classification of things. And so we've already seen this a few times in class. But it's really good to sort of go through this mental exercise of how do we look at a ton of different things and sort of group them together in some kind of classification. So even if they don't have a classification of being similar things, like maybe they're totally different colors and shapes and whatnot, maybe just the fact that they're all sitting on your desk is enough to classify them all together. That maybe their attributes that they have is their position on your desk, and maybe some kind of name or something, or the material that they're made out of. That can all be classified. So the class would be like things on my desk, and then the private elements of that would be the positions and the colors and the materials and whatnot. So it's really important, just as a mental exercise, to be able to look at something and be able to group them together, and sort of make them as generic as possible, that still makes them useful. So these guys should be easy. What are these all a classification of?
Video game?
Yeah. And actually, what kind of things might we, what kind of private parts to them might they have? What kind of data would we care about?
Well, they would all have mostly different. I'm sure there would be some overlap, but they'd all have a lot of different things that they care about.
So yeah, what's an example of maybe it's a store that's selling them. What things might the store need to
Oh,
keep track of?
um, their cost maybe.
Okay.
Probably. Um, how many of them there are?
Okay, how many are in stock? Sure. What kind of questions might people ask before they buy a video game that would allow them to play it, for example?
Uh, what platform they run on?
Yeah. Okay. So the console, yeah, the platform. That's very important. What else?
Their genre.
Yeah, that's also a very useful thing to store. Yeah, yeah, things along those lines. So yeah, how many things are in stock? Um, Maybe their rating. Um, yeah, those kinds of things um, are useful to store about them. Um, okay, what about these? What are these all classifications of?
Cars.
Yeah, these are all instances of cars. And so what might we store? What might be the private parts of these?
Um, their name,
Yeah,
their manufacturer,
yeah,
maybe their price,
yeah. So maybe it's a dealership and they need to keep track of the price.
their different specifications,
Yeah,
their color. I don't know.
yeah. Color is pretty useful when you're trying to sell a car. In this strange day and age, maybe the number of wheels that are attached, how big the wheels are, um, maybe the year. People
Right.
seem to fixate on the years of vehicles for some reason. Um, yeah, so things like that. Being able to look at things. Okay, let's go with the last one. This is the tricky one. What do all these things have in common?
They all get some kind of input,
Yeah,
like a moving input.
yeah. It controls the mouse. So
Mm.
these are all human interface devices that control the mouse or the pointer in general. Yeah. So and then what things might we private things might we have for these guys?
Uh,
It's a bit tricky. It's much harder.
would they have like a refresh rate or an update rate?
Yeah, so that's a pretty good attribute to have. Um, yeah, how many samples should we expect from it at any given moment? Maybe how it's connected. Um, Maybe some kind of manufacturer ID or a driver number that's associated with it. Things sort of abstract things like that. But yeah, being able to just store things like that because then the computer is able to understand the data that it's getting from it.
Mm-hmm.
Um, okay, cool. So that's classes. Actually, yeah, I guess. And any questions about classes? We'll look at the Pokemon example, and that's a pretty good use of a class.
I don't have any questions about classes.
Okay, cool. So this is now where I harp on people about documentation. So documentation is really, 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 really important. I cannot overstate the importance of documentation. Um, it is a useful way of just leaving a note to ourselves or even other people in the future. Yes, our code can time travel into the future. It's a wonderful thing. But the issue is that we forget, and we forget pretty quickly. I mean, I'll open up code that's not even a month old, and maybe it was some kind of rush project where somebody was just needed me to hack something together, and then it worked for a few weeks, and then they changed something or they needed to do something more, and they're like, oh hey, could you made that hack? Could you just like go in and make it do more things? And I open it up, and if I didn't leave really good documentation, I would be in trouble. Like I've had projects where it was really rushed. I coded it really quickly, just as like a proof of concept, and then people asked me to just keep building on it, and it probably would have been easier for me just to rewrite it from scratch because I didn't leave enough comments. And that happens, but it's something that we should definitely try to avoid, not leaving comments. So what happens over time is that we forget what were we doing, where we left off. I have a lot of projects that are 90% of the way done. The code's written, it's there, and it's probably semi-functional, but to really finish the project would require only a few more lines of code out of hundreds or thousands of lines. But I forgot where I left off because maybe I didn't leave comments. And so a lot of my code, I have comments that are just to-do comments saying like, hey, do this, do that, only partially here, need to test this part, things like that. So comments are really important. And there's something called code rot. And what happens is that our code may be very robust and may be written very well for that time. But what happens is that the world around us, all of the code around our code is always changing. Libraries are updating. I mean, Java itself has evolved a great deal in the time that I've used it. And a lot of the bleeding edge classes that I used when I first started using Java are now totally obsolete and are not supported and don't work at all. And well, I mean, it does work, but it practically doesn't work in the most recent version of Java. And so not only do you always have to be adapting and learning about the changes, but your code, your old code may continue running for years and years and years. I have code that's running in banks and in India, and I have code that's running in toll systems in Germany, and I didn't intend on that code. First thing is, I didn't intend on that code running in the real world. It was just for testing. But what happened though is that I knew that changes were going to happen with Java. There were certain classes that were going to change their behaviors, and so I was able to. I wrote into the code comments saying this change is going to happen in 5 years because I was running a newer version of Java. I knew what changes would happen, and so I was able to leave comments saying, yeah, this block of code will need to change in this way in this many years in this Java version because I saw it changing. And anytime we have to do any kind of hack where maybe you're using a library that wasn't quite implemented correctly, and it works pretty good, but you just have to do a minor tweak of the output. If they ever go and actually fix the library, then what happens is that your code now goes in, and maybe somebody has like an add one function or method, and instead it adds 3. And so what you do is that every time you call it, you just subtract it by 2 as a hack. And that would work as fine, perfectly fine until the moment that they fix it. And then now that breaks your code. So leaving a comment behind saying, hey, I did this hack to make this work. That way, when somebody goes to open up your code, even you, maybe you're paid a good chunk of money to go in and fix your code, having a comment that's very clear of why you're doing it and whatnot, and then you notice, oh, hey, the library got updated, you can then go in and remove that hack, and then you're off to the races. I know a lot of cases where companies will pay just a blanket amount of money to go in and fix your code after you've retired or whatnot. Maybe they say, hey, fix the code, here's $20,000. And if you've left really, really good documentation, then that might take you, an hour or a few minutes to go in and fix. When if you didn't do any kind of documentation, you might have to rewrite it, and that might take you months to fix or to figure out, because maybe that code was you had written years ago. So leaving really good comments is really, really important. I cannot emphasize that enough. And so we have two different kinds of comments. We have our inline comments, which typically are just at the end of a line of code, but it also could just be a dedicated line. And then we have these things called block comments. These are typically used, block comments are typically used for multiple lines of comments. And then Jeff showed you guys, was it last week or yeah, the Java doc. And so whenever we Google like Java API, scanner or something like that, we saw this really nifty website, right? Let me just pull it up. Come on. So we saw like this really nifty website that had like, the method name, the prototype, a description, the parameters, what it returns, if it throws any errors. This really nifty website that has all of this these details. And one of the major things why people love Java so much is because it's very well documented. Not all languages have a centralized documentation. That's been one of the biggest griefs that people have with C and C++, is that there may be websites that look very much like this, but they're not centralized or approved by the people who are releasing the language. So Java is a very rare exception, and like Python has taken this over as well, doing this same documentation where the code itself has in it these block comments that have all of that data. And it's very, very useful, because suddenly now I could collapse the code and just read the documentation, just read this block comment, and I should be able to get an idea of exactly what the code should be doing. And so if the code is ever misbehaving, I can always read the block comment and then read the code below and see if they actually correspond. A lot of times when I'm implementing algorithms, or even if I'm just doing an assignment, a lot of times what I'll do is I'll paste the actual description of what needs to be done inside of the block comment. That way, when I'm coding, I can just look just above my code, and I can see a whole description of exactly what my code needs to be doing. And so we have a few specialized flags for things. So for example, we have the author, that would be classes, and there could be multiple authors. So you just have multiple lines that say author, and then the author, and that might be your name and an email address or a phone number, or what office you're in, or whatnot. Version number. Versions are really, really important, especially when you have lots of copies of your code floating around. And you can take the version number, and you might even have the version number as a variable up above, and you might actually display that in the interface, or whenever you run the program, it also prints out the version number, or has it as part of the screen. that way, if somebody's complaining about, hey, this feature doesn't work, you can look at the version number and go, oh yeah, because you're using code that's over a year old. Here, let's use this version. It's newer and that works. Parameters or arguments that a method or constructor might have, return types that methods have, at exception. This is also synonymous with at throws. Essentially, if your code is going to throw an exception or could throw an exception, you should probably label what that is. And here is the spot where you can give an actual explanation of why it might throw an exception. It might throw a strange, strange sounding exception. And this is sort of your opportunity to inform the user why it's throwing that exception, or why you thought that it made sense. And then this @C is really useful. You should just use this everywhere. @C is essentially anywhere where you want to post any kind of link or resource, like, hey, this code was provided from blah blah blah. This is essentially how you credit your sources, and this is how you build up a reputation. So a lot of times when I'm implementing some kind of algorithm, I might post the textbook that I got the algorithm out of, or maybe a Wikipedia page where the algorithm is described. So if anyone's unclear of what my code's doing, they could just go to it, or maybe some kind of visualizer, so like a GIF that has like showing the mechanical operation of what's happening. And then if they have any questions, they could then look at my code with that picture in mind, or that diagram in mind, or the explanation from Wikipedia in mind, and then look at the code, and that would help them understand the code better. So yeah, use this @C extensively. It's a easy way of storing links, or storing online discussions or whatever, to be able to toggle back and forth between your code and some kind of knowledge or understanding of what your code should be doing. Yeah, so that's JavaDoc. Any questions about JavaDoc?
No, I don't think I have any questions about JavaDoc.
Cool. Yeah.
One thing, actually, so you have @ and then the keyword, and then the rest of that line is
Yeah.
in reference is part of that? Okay.
Yeah. And so typically, like with the returns in param, people put like the type, and then maybe the name of the type, and maybe even an explanation of how it's used. And so we saw here that like this, right here, there was like pattern, and then like this was the string. This is literally what came after the @param right here. And so notice how people could just say like the next token for returns. But what you will see sometimes, let's see if I can find it. Well, sometimes what you'll see is like the type, and then a name, and then maybe the dash, and then the description of what it is. These are all terrible examples. But yeah, so that's how you use it. It's the whole line that comes after the @ notation. And yeah, anything that you put below that line, then you're gonna end up going into the space where it's this descriptor of this code here. Anything that's doesn't have the @ notation is just going to go into the blob that's the description.
That makes sense.
Okie dokie. Yeah, so really useful. And actually, as an exercise, what Jeff sometimes will do is he'll write all of the code with the JavaDoc, and then he'll export. He'll generate the JavaDoc, which is literally just JavaDoc space and then the name of the file. And that generates the web page, and then he'll just give everyone the web page with all the Java doc, but doesn't have any of the code, and they have to figure out how to write the code. And it's a useful thing to share, because then you can just give somebody the Java doc, somebody who's not code inclined at all. You can generate the Java doc, which are just web pages, upload it to your website, or just give them the page, just give them the HTML pages, and they should be able to figure out how to open that and read it. And then that also will give them an idea of what your code is doing, and how you've sort of broken up the things that the things that your code is doing. And that helps then establish a vocabulary, because now they know the names of things that you've given things, and that allows them to actually talk to you with the same kind of vocabulary. So that's very, very useful. Trying to level the playing field, because then people actually they know how to talk to you, and you now know how to talk to them, because you've given them the tools to interact. Yeah, so Java doc, super duper useful. Okay, let's review our Pokemons. So they are an excellent example of classes. Okay, so let's go to main real quick. All right. Okay, so we got our Pokemon. And have you seen me do the Pokemon example yet?
I was there for, I think I missed the beginning, but I was there for most of it.
Okay. So yeah, just a quick review then. So in main, we're able to call these default constructors. We're able to make arrays of our type of Pokemon, and this is how you do it. Previously, I had it written wrong. I had it written for how you do it in C++, and I just corrected that yesterday. And this is also on the GitHub. And then we can insert into specific spots in this array new Pokemon that we create. And so this is the default constructor here, calling the default constructor. And this here is calling an overloaded constructor that actually has useful data in it. And so notice that it has 4 arguments. And those 4 arguments correspond to the 4 private parts that a Pokemon has in this case. And you could always add more, but just in this example, there were 4 private parts of a Pokemon. And so we can do things like this, where we create a Pokemon and then we assign it to its own instance variable. So like SQU is Squirtle, and then we can also stuff Squirtle into the Pokédex. So not only do we have a name for Squirtle's instance, but we also have a spot in the array where he lives as well, as opposed to Bulbasaur, where Bulbasaur only lives in a particular spot in the array. Yeah, and then we did the same thing with Pika, right? We made a Pika, and then so we have a name for Pikachu, and we've also stuffed it into the Pokédex as well. And then all we do for main is we can call, Pika.print, or we could even say Pokédex at 2 .print, and that's going to call this print function that belongs to the class. And so it'd print out the name, the attack, and the speed. And then to be able to do battle with them, right, I could say SQU.battle, or I could say Pokédex at 1, square bracket 1, .battle, and then here's the other Pokemon. And so what happens is that here, this Pokédex at 0, this Pokemon, which is Bulbasaur, gets passed to battle, which hasn't been written yet, and so that's other. So essentially, whenever we say other, in this case here, we are talking about Bulbasaur. So if we say other.hp, we're getting Bulbasaur's HP. But if we say HP, then we're getting whose HP are we getting if we just say HP or this HP inside of this battle here.
Sorry, I have background noise. That should be, in this case, it would be Squirtle's HP.
Yeah, exactly. Yeah. Yep. And so that's how we tell the difference between the two Pokemon, is that we have this or this dot, whatever it is, this dot attack, and then we can say other dot attack to be able to figure out who we're talking about. And the idea about battle is that battle only knows about what it's been given and what it is itself. So battle is inside of a Pokemon instance, and then it's also given another Pokemon. But battle has no idea of Pokédex, right? Battle has no knowledge of Pokédex or anything inside of main. It only has access to what it itself is, which is a Pokemon, and the other Pokemon that it's been given. Okie dokie. Yeah, so that's that. And then we have setters and getters. These are super duper important, and every class should have these. And so here's set HP, for example. And so we get a new HP, and then we make sure that if it is smaller than 0, what do we do? So say I put in negative 5,000. What would HP be at the end of this?
At the end of set HP?
Yeah.
0.
Yeah, exactly. And so the idea being is that Pokemon can only faint, so their HP stops at 0. If this was Dungeons and Dragons, we might have something for if the HP is below 10, negative 10, that they die, right?
Yeah.
But in the sense of Pokemon, we only faint. So that's why we would write code like this, and then we can stop at 0. This also helps us in our battle code make it much easier, because we can just assign damage and go into the negative space and we're okay. As opposed to if we had made HP unsigned where it could only be positive, what would happen is that if you even went to -1, you'd become this really, really big positive number, in the millions or billions size. So in a lot of cases, it just makes it easier to just have something that is like an integer that can have negative numbers. And because Pokemon HP isn't an enormously high positive number, we can use that negative space to sort of make our code a little bit easier. Versus the getters, right? The getters are very straightforward, right? They're just returning what they're getting. And this is very typical, because you don't want to expose your variables. You don't want to expose name or HP, because maybe somebody could just go in and reach in and change it in a way that might break your code. So what you do is that for all the getters, you just return things. And what you can do too is that your name that's internal to your code can be different than the thing that they're getting. So maybe inside the code, instead of name, we had instead called this guy here, we had called this Pokename or something, but that the method, the getter, could still just be getName, and here we would just say this.Pokename. So you can sort of add a layer of abstraction and sort of hide from the user of your code what your things are actually called internally. And that's a very useful strategy, because maybe throughout your code's life, the internal bits change, but all of the public facing stuff stay the same, in the sense that this name right here, this prototype here, the public string get name, that never changes. The interface, the way that people interact with your code never changes, but that maybe the internal parts change. Maybe the name, instead of being a string, was a character array, and that you in here you assemble the character array and then you return it to them. That as far as they're concerned, they just called get name and they got a string. So if the underlying implementation of what the code looks like could be different, but as long as the behavior stays the same, then you're good. And that's the beauty. That's the beauty of encapsulation and of Java and using these methods, is that you can hide your private parts, and that the public parts you're exposing, but it also allows you to change how you're doing things as long as you still behave in the same way. And then let's do constructors. So we have a default constructor here. And what we're doing is that we're setting it in a way that will be very obvious if we accidentally do something with this Pokemon. Like if we printed it or if we did battle with it, it would be very clear that, hey, this Pokemon was never set up. That its HP is -9, which will immediately mean that it faints. And that it doesn't do any attack and it has no speed, and that whenever we print out its name, we get none. And it might change. You might change the attack and the speed to like the number 1 or something. Just that if you do battle with 2 Pokemon that are nuns, that eventually the battle will resolve depending on how your battle code is written. So this isn't particularly useful, but it's good to have a default constructor just in case you accidentally make a default Pokemon and you try to use it, to make it as clear as possible what's going on. Okay, and then the final constructor, the one that's actually useful, is the one where we passed in the name, the HP, the attack, and the speed, and all we're doing is that we're just setting it. Something to be mindful is that the new word is reserved. If we type it into any decent editor, we'll notice that it gets highlighted, that the coloring changes for it because it's a reserved word. So something to be careful of. I like saying new name, new HP, new attack, and new speed because that helps me distinguish between these. You could always just say this dot name, and then we could change this to name. We could just get rid of the new and just have name. So it'd say this dot name equals new name. Yeah, and I think that you should jump over to Jeff's session because class time is almost soon. Thanks for being here.
Yeah, thank you.
Yeah. Okay. All right.